This is P4 Rational Exponents and Radicals, day number 3. We've already looked at the properties of exponents and rational exponents, and we've looked at radicals. And so this third day we are looking at getting into different types of problems that get into the properties and laws a little bit deeper. So if we look at page number 35, problem number 4, this is our first example. We have 2 times x to the 3 halves times 4x to the negative 1/2. Since I've got a term here with a positive exponent and a term with a negative exponent, I'm going to create a fraction bar, and I'm going to drop this 4x to the negative 1/2 down to the denominator to be 4x to the positive 1/2. So that will cancel out on the numerator. And at this point, I need to distribute the exponent of 1/2 to both the 4 and the x. And so what I will get is I will get 2x to the 3 halves over 4 to the 1/2 and x to the 1/2. At this point, I need to realize that 4 to the 1/2 is the same thing as the square root of 4, which is 2. So I can rewrite this as 2 times x to the 3 halves over 2 times x to the 1/2. And the 2's will cancel because 2 over 2 is 1. And with x as the common base for the numerator and denominator, I can subtract these exponents, and I get x to the 3 halves minus the 1/2, and 3 halves minus 1/2 is 2 halves, or 1. And so our final answer is x to the first, or just x. Our second example comes from page 35, problem number 50. We have 4 times x to the 6th times y to the 8th, all of that with an exponent of 3 halves on the outside. So I need to bring that in and multiply that exponent times the exponent on the 4, which is a 1. I need to multiply that times the exponent of 6 and multiply by the exponent of 8. Every time I distribute an exponent in from outside the parentheses, it is multiplied by all the exponents on the inside. And so at this point, I have 4 to the 3 halves. I have y to the, 6 times 3 is 18, so 18 over 2. And then y to the 8th, you're going to multiply 8 times 3 halves, and that's an x there, and you're going to get y to the 24 over 2. So I have 4 to the 3 halves, x to the 18 halves, and y to the 24 halves. Again, with the denominator of 2 on the 4, that is going to be the square root of 4. And I could take the square root before I take the exponent of 3. So I have the square root of 4 to the 3rd power. On the exponent for x, I have 18 over 2, which is 9. So x to the 9th. And the exponent on y, 24 divided by 2 is 12, so I get y to the 12th. So if I take the square root of 4, I get 2 to the 3rd, which is 8. And so really, I just need to simplify that radical there and with the exponent of 3, and my final answer is 8 x to the 9th and y to the 12th. Moving on to the next example here, we are looking at page 35, problem number 58. I have y to the 10th times z to the negative 5, all to the 1/5 exponent, over y to the negative 2, z to the 3rd, all with an exponent of 1/3. So again, I need to distribute this exponent from the outside. I'm going to get y to the 10/5 and z to the negative 5/5 over, again with this 1/3 exponent, I'm going to distribute into the y to the negative 2 and z cubed. And negative 2 times 1/3 is going to give me negative 2/3. And then z is going to have 3/3. Now at this point I can start to kind of simplify, and I'm going to move these terms with the variables with the negative exponents. So here I've got a negative 2/3 because I'm going to move that to the numerator to be y to the positive 2/3, and that cancels out the denominator. And this z to the negative 5/5 is going to be moved down and get z to the negative 5/5 down here, or positive 5/5. And that cancels out the numerator. Now, I have y to the 10/5. So I'm going to rewrite this and clean this up here. I've got y to the 2/3. 10/5 is 2, so I've got y squared. Z to the 3/3, that's z to the first. And 5/5 is also z to the first. Now I've got common variables base values here of y and common base values here of z. I am going to add the exponents. So I get y and 2/3 plus the 2. And z times z is z squared. Now 2/3 plus 2 is 2 and 2/3. To write that as an improper fraction, I multiply 2 times the 3 to get 6, plus the 2 on the top to get 8, and that is 8/3. So my final answer here is y to the 8/3 over z squared. Okay, here we are looking at rationalizing the denominator. So when we're looking at rationalizing a denominator, that means we have to do something. We're going to multiply this fraction so that we can get rid of the radical in the denominator here. And since this is a radical with a value of 2, that means I need 2 of whatever factor is listed underneath the radical, which means I need another 3. But I need it, that's a square root of 3 times a square root of 3. So that's going to give me the square root of 3 squared. And the square root of 3 squared shows that the radical value of 2 is the same as the exponent, and those cancel out to give a 3. And if I'm going to multiply the denominator by the square root of 3, I have to multiply the numerator by the square root of 3 also. And that's going to give me 12 times the square root of 3. And the denominator, as we saw here, is going to cancel out and give a value of 3. So here I've got 2 whole values, integers, 12 over 3, which is going to be simplified as 4, and the square root of 3 is going to go with the 4. So I get 4 times the square root of 3. And another example of rationalizing the denominator is going to be page 35, problem number 64a. Here I've got the cube root of 4. And 4 actually can be broken down to be 2 times 2, which is 2 squared. So I have 2 of these factors of 2. I need a third. So I can look at this as 1 over the cube root of 2 squared. So I need another 2 in here to make that exponent of 3. So that gives me, I need the cube root of 2, so that when I put these together, I have 2 squared times 2, and this is a 3 out here, which is 2 to the third. And the cube root of 2 to the third, the radical value now is the same as the exponent, so those will cancel out to give me a 2. And so since I'm multiplying the denominator by the cube root of 2, I am also multiplying the numerator by the cube root of 2. And 1 times the cube root of 2 is the cube root of 2. And now I know from the denominator, in working this out, my denominator is 2. I cannot simplify these. One is under a radical and one is an integer, and we are done. So the cube root of 2 over 2. And that does it. We are done with section P4.